Okay, so to start with, we're going to use some exponent properties. This is actually just review, except your exponents are fractions, which changes absolutely nothing. So if you're multiplying terms together, you need to add their exponents. So on this one, you'd end up with 12 to the 2/3. Another reminder, if you are multiplying things together, like you add the exponents on x times x, but not x times y, you can't simplify unless the bases are the exact same numbers. So like I could do that one because it was 12 and 12, but I couldn't multiply this one together. I would just have to leave it as is. If you have a negative exponent, remember that makes it 1 over or move to the denominator. So on this one, the only thing you would do is move your w to the 2/3 down. Again, I'm multiplying, so I will multiply my 4 times 6 and add my exponents on my x to the 1/3 and my x to the 5/3, or 4/5, sorry. So if you're adding those, they're fractions, so get a common denominator, and you'll end up with 5/15 plus 12/15 is 17/15. You could use a calculator to save a little bit of time, but it's not bad to do without. End up with 24x to the 17/15. So on this one, you have things inside the parentheses that are being raised to a power. So you have a monomial inside there being raised to the 3/4. So you'll multiply your exponents together this time. So you'll have to take your 2/5 times 3/4 for your w. Don't forget that y is to the first, so you'll have 1 times 3/4. The 4 on the outside is just kind of chilling there. So you multiply your exponents together, simplify, and you'd end up with 4w to the 3/10, y to the 3/4. When you're dividing, first thing I see in this one is a negative exponent, so I would move that c to the thirds to the top of my fraction, and then I'm just going to rewrite everything. But when you're dividing, you're going to subtract your exponents. Usually I do like largest number exponent minus smaller number exponent, and then like leave your result where the larger number was at. So my a's will end up on top because 1 is bigger than 5/6. I can also divide 56 by 7 and get 8. So number divided by number, work one variable at a time. So take my 1 minus my 5/6 for my powers on my a, and I'd have a to the 1/6. Again, that goes on top because 1 is bigger than 5/6, so your leftovers would go up there. No other like terms. I just realized I didn't put my third on my c there. Sorry, should be a 3 on that c. Again, take it one set of values at a time. So you could simplify your 9 over 12. You're going to end up with a 3/4 if you do that. And then if you take your y's, you could subtract 5 minus 3/2, which let me do real quick. Oops, hang on. 5 over 1 minus 3 over 2, multiply by 2 over 2. You're going to end up with 7 over 2. 5 was larger than 1.5, so your 7/2 would go on top. And then for your z's, you have 8 minus 2/3, common denominator. You'll end up with 22 over 3. Wait, hold up. 8 was the larger value, so my result should end up on bottom there. And there's my final. Okay, that was basically all review. Things were just fractions. No big deal. New part is we can switch actually between exponent form and radical form. So say I have x to the 3/4. That's really the same thing as the 4th root of x to the 3rd, or the 4th root, think of that as a group, of x to the 3rd. So your denominator is the index on your radical, and the power on your variable is just the top. The numerator is the power on your variable. So if I switch this to radical form, my index on my radical is going to be 3, so 3rd root, and then I'm going to have it raised to the 2nd power. I find it easier to put the power like outside on the whole thing, because then I don't have to square 125. I just do the cube root and then square it, which is a lot easier. So cube root of 125 is 5. I need to square it. I end up with 25. 8 to the negative 4/3, negative exponent, so let's make it 1 over 8 to the 4/3. Switch it so that it is the third root of 8 raised to the 4th power. And then you have third root of 8 is 2. 2 to the 4th is 16, 1 over 16. This one you have to be a little bit careful to realize the exponent is really only with the 3/5 because order of operations, exponents, and then multiply by your -1. So leave the -1 and rewrite your 32 as the 5th root of 32 to the 3rd. You break that 32 down, we've done it a lot. You end up with the 5th root of 32 being 2, which you would then take to your power of 3, and finally multiply by your -1 to get -8. This is a 1/5 power. Everything is being raised to it, so all of that is going to go inside my radical, and it will be the 5th root. Really, it's just the first power since my numerator is 1, which doesn't really change anything. Let's break down that 96 and see if we can bring anything out. Oh, there's 5 2's, so I'll have a 2 on the outside of my 5th root, because I could take the 5th root of 2 to the 5th, 3's left inside, I get x and y on the outside, and then 2 factors of y left inside. Again, careful, the exponent's only with the x, so you'll have 2 times the square root of x to the first, or just 2 times the square root of x. You can go backwards, so you can switch from radicals to exponents. So make sure you put your power on top, your index on your radical on bottom. All there is to it. This one, remember, is to the first, so you'd have 7 to the 1/9 power. If your index isn't written on your radical, don't forget it's a square root, so this will be 6 to the 5/2 power. The next one has a variable, but it's really no different. It's the second power and third root, so x to the 2/3. I'm going to simplify a little bit before we switch this one to exponent form. So square root of 9 is 3, and then I can also take 2 groups of 2 factors of z out, and then I'll have my 3z squared, and since it's the square root of y, it'll be y to the 1/2 in exponent form. That's pretty much it, so hopefully it goes all right. If you have questions, let me know.